Okay, let's continue the story of units of measurement. So we already talked about the metric system, and I taught you the dimensional analysis way of converting from one metric unit to another. Now I just want to introduce the topic of SI units. This is an international system of units used all over the world, and these are the 7 SI units. For length, everyone's supposed to measure in meters, mass in kilograms. Notice the lowercase k for kilo, not uppercase. Time, seconds, temperature, capital K, that stands for Kelvin. Amount of a substance is in moles. Electric current, amperes, and luminosity or luminous intensity is candela. These two we don't really use in this class, but the rest we will be using. Now, there are units that are called derived units. Volume, the one I had mentioned earlier with the metric system, I told you we usually use liters for our metric units for volume. But derived means that you can actually figure out volume if you know the length. So basically, it's derived from meters cubed or centimeters cubed. So for volume, this is your derived units. I have this down here. I don't know if you can see this. There you go, derived units. For volume, 1 deciliter is equal to 1 meter cubed, and 1 milliliter is equal to 1 centimeter cubed. So you should know those conversions. Density, you probably remember density from intro chemistry classes. Density is mass per unit volume. So in order to calculate density, you need to get the mass and divide it by the volume. Well, what units should we use? Well, it could be in grams per milliliter, or it could be in grams per centimeter cubed, or it could be in grams per liter. Just depends on what the thing that you are measuring is. So let me give you a quick density problem. Finding density is super easy. Using density as a conversion factor is also super easy. You can always use density to convert between mass and volume and mass. But let's say I gave you a super easy question where it just says calculate the density of a substance that is, let's see, this is wintergreen oil. I have a 28.1 gram sample of wintergreen oil, and the volume of the sample is 23.7 milliliters. So you got 3 sig figs and 3 sig figs. So all you do is put your mass on the top, 28.1 grams, and you put your volume on the bottom, 23.7 milliliters, and you get your, what did I do with my calculator? All right, here we go. Go 28.1. Helps if I turn it on. 28.1 divided by 23.7. Your calculator value is 1.185654008. Obviously, too many sig figs. How many sig figs do we need to round it to? This is 3 and this is 3. These are both measured quantities, so your final answer has to be 3 sig figs. So it'd be 1.185. The 5 is 5 or higher, so we round up. So your final answer has to be 1.19. And don't forget the units, grams per milliliter. Okay? All right, so that's an easy question. Let's do another one. Let's say I give you the density. So a problem where density is given to you, and I either give you mass or I give you volume, and you have to find the other one. So let's say let's see, what do I have here? I have the density of gasoline. Density of gasoline is 0.718 grams per milliliter. gasoline is less dense than water. Water has a density of about 1 gram per mil at 4 degrees Celsius. So anything that has a density less than water is going to float on top of water. You remember that from intro chem. So that's the density of gasoline. I have 454 grams of gasoline. So 454 grams of gasoline, and I want to know the volume. So I'm going to use density as a conversion factor using dimensional analysis. Now, when you use dimensional analysis, remember, you want to, the unit you want to cancel, you put down here. The unit you want to find is up here. So I want grams down here and milliliters here. So that means this is 0.71818 grams per 1 milliliter. That's what this value is. So what are you going to do? You're going to flip it over, put the 0.718 down here, 1 milliliter here, cancel, plug it into your calculator, 454 divided by 0.718, and you end up with 632.3119777. Are you allowed to put all those digits in your answer? No. You round it to the right number of sig figs. This is 4 and this is 4, so your final answer would be 632 milliliters. Don't forget the units. From now till the end of the semester, units and sig figs, super important. Don't forget to pay attention to both at all times. Okay, what if, so that's density. Density problems should be pretty straightforward. Let me try to find you a more difficult problem. I should have them here somewhere. Okay. Before I jump into that, what if I was using English units? Let's say I know that something is, let's say, 3.0 feet. And I want to convert that to centimeters. How do I do that? First, you want to go from feet to inches, and then you go from inches to centimeters. You know that 1 foot is equal to 12 inches. This is a definition, okay? And you should know that 1 inch is 2.54 centimeters. Definition, all right? So we are limited, so these are unlimited number of sig figs. We're limited by these 2 sig figs now. So we're going to go 3.0 feet. We'll go 1 foot is 12 inches. And then we'll go 1 inch is 2.54 centimeters. Or let's say, let me give it an extra sig fig. Let's put a 0 here. So it's 3.00, 3.00. So this is 3 sig figs. How many sig figs is this? This is not 2. This is infinite because this is a definition. This is an exact number. How many sig figs is this? This is also infinite. So I am focusing on the first measured quantity, not these guys. These are not measured. These are definitions. So I'm going to plug it into my calculator. 3 times 12 is 36 times 2.54. 2.54. Oh, gosh. 36 times 2.54. Final answer is 91.44. How many sig figs do I need? This is 3, so 91.4 centimeters. Okay? Now, let's make it a bit more difficult. What if I have the density of something? Again, this is the good use of dimensional analysis when you're trying to convert from units here. Okay, I have the density of mercury. Hg is mercury, the end of chapter 1, I'm going to give you a heads up on all the elements that you're going to need to know in chapter 2, because chapter 2 we dive right into elements and compounds and naming things. So I will, but anyway, Hg is mercury. So I was given the density of mercury as 13.59 grams per centimeter cubed. Remember, density is mass per volume. And I want to convert that to pounds per feet cubed. Okay, so I am going to be given a few conversion factors. I know that 1 foot is 12 inches. I know that 1 inch is 2.54 centimeters. Those things you should know. The relationship between pounds and grams, I'll give that to you. 1 pound is equal to 453.6 grams. So these are conversion factors I'm going to use. All right, so have these in your notes. And now let's set it up using dimensional analysis. So 13.59 grams per centimeter cubed. And remember, what am I looking for at the end? At the end, I'm looking for pounds per feet cubed. That's what I'm looking for. Okay, so let's focus on one and then we'll focus on the other. So I want the grams to be converted to pounds. Easy enough. I'm going to use this conversion factor here. Since this is grams, I'm going to put grams down here. So 453.6 grams is 1 pound. Excellent. Now I've got pounds in the numerator. Good. Now I want to somehow convert centimeters cubed to feet cubed. All right. Let's first go from centimeters to inches. Okay. So I know that if I put centimeters here and inches here, I know that I have 1 inch is 2.54 centimeters. But centimeters will not cancel with centimeters cubed, right? So I need to cube this whole thing. This whole thing has to be cubed. The number is cubed and the units are cubed. When you do that, then centimeters cubed can be canceled out with centimeters cubed, all right? Because the 1 inch is 2.54 centimeters, that's great for just centimeters, but we want centimeters cubed, all right? And then my last conversion factor, I haven't picked up my calculator yet, I'm going to pick it up at the end. My last conversion factor, I want to go to feet cubed, because now I've canceled my centimeters cubed. Now I've got inches cubed, and I want to switch it over to feet cubed. So if I put inches here and feet here, I know that 1 foot is 12 inches. Very nice. But will inches cancel out with inches cubed? No. So what do I have to do? I have to cube the whole thing. This is really important. You're going to see this in your first math lab that is due pretty quickly. So just make sure you know how to cube the whole thing or square the whole thing, or depending on what it is that they're asking you to do. All right, so 13.59 divided by this times 2.54 cubed times 12 cubed equals, everything's going to cancel, and you end up with pounds per feet cubed, and your answer is going to be, I have it already written down here, 848.4 pounds per feet cubed. Okay, why did I go with this many sig figs? You'll look at this and say, but Dr. Wabi, this is only 2 sig figs. No, it isn't. You guys know that this is a definition. So we go with the measured quantity that gave me 4 sig figs. These guys have infinite number of sig figs. This is just 4 sig figs. I have this as my final answer. Okay, good. We'll do one more video and then we'll be done with chapter 1.